My name is Ron Rodriguez. I'm the team lead of Group 28 in ENCM 511 Fall 2005. I'm going to go through the code and explain the operation of the program, and then I'm going to program the board and show it in operation. So this is the int main function of the program. The first thing that happens is that we initialize, which is to set the tris A bits for RA4 and RA8 to 1 for input on push button PB0 and PB1. Then we set the tris B 5, 6, and 7 bits to 0 as output on pin 14 RB5, RB6, and RB7. We also set pull up high on the IO CPU bits B for B8 and A4 by setting those registers equal to 1. So RB8 and RA4 are set for pull up high. Then after initialization, it enters the super loop. While 1, the LEDs are all set to 0. LED 0, 1, and 2 are set to 0. And then the polling begins. If push button 0 is equal to 1 or high, and push button 1 is equal to high, then both buttons aren't depressed, they're not pushed. So we set all of the lights LED 0, 1, and 2 to 0. Else, if push button 0 is low, and push button 1 is also low, meaning both are pressed, we set LED2 to on or equal to 1. Else, if push button 0 is 0 and push button 1 is 1 or high, that means that push button 0 has been pushed and push button 1 has not been pushed. Then we call the function blink 0.25, which blinks for 0.25 seconds on and 0.25 seconds off for LED 0. And then finally, if push button 0 is equal to 1 or not pressed, and push button 1 is equal to 0 or pressed, then we call the function blink 2 seconds, which blinks the LED1 for 2 seconds on and 2 seconds off. Else, all of the lights are set to 0 or off. Let's go through those functions. Blink 0.25 is a function that has a for loop that counts to 34,000 and performs integer division, costing 19 cycles, clock cycles. So it divides 1,000 by 50, 34,000 times, which was modified empirically after a calculation was performed, which was initially calculated to be 50 to 631 to get 1,000,000 cycles for 0.25 seconds. So we turn the LED1 on, wait for 0.25 seconds by performing integer division for 34,000 cycles, set it to off, LED 0 is off, and then wait for 0.25 seconds doing integer division for 34,000 cycles. Similarly, blink 2 seconds performs the same operation of integer division in a loop, for loop up to 34,000 cycles. But it does this 8 times to make up. So as a nested loop where it counts to 8, doing these for loop to 34,000 of integer division. So that's how it makes up the blink 2.5. So now we're going to show you the operation of the board, which has been pre-programmed. And that should be right here. So I'm going to press PB0, and that gives the fast 0.25 second LED blinking. No buttons, no lights. Push PB1, gives the slow 2 second blinking. And then I'm going to push both push buttons, PB0 and PB1, and we get the LED2 turning on alone. Of course, there's a little glitch where it picks up just one of the button pushes first. And then no buttons, no lights. So that is the full operation of the program. And my name is Ron Rodriguez, Group 28, and ENCM 511. Thank you.